Have you ever wondered how the sun, a brilliant ball of fire floating in the sky, has been burning for billions of years without running out of fuel? The same sun that warms your skin, grows the food you eat, and lights up every sunrise and sunset. It seems almost magical, but the secret lies in an incredible process happening deep inside the sun's core, a process called nuclear fusion. Without it, there would be no light, no warmth, and no life on Earth. At the heart of the sun, where temperatures soar to about 15 million degrees Celsius, and the pressure is unimaginably intense, hydrogen atoms are packed so tightly together that they begin to merge. Normally, atoms repel each other because of their positive charges. But in the sun's core, the extreme heat gives the hydrogen atoms so much energy that they collide with enough force to overcome this repulsion. When two hydrogen atoms slam into each other with enough energy, they fuse to form a new element, helium. This fusion reaction doesn't just create helium. It also releases an enormous amount of energy. Here's how. When hydrogen atoms fuse into helium, the new helium atom weighs slightly less than the two hydrogen atoms combined. That tiny bit of missing mass doesn't just vanish. Instead, it is transformed into energy, following Albert Einstein's famous equation E=mc². In this equation, E represents energy, M stands for mass, and C is the speed of light. Because the speed of light is such a huge number, even a small amount of mass produces an incredible amount of energy. To put it into perspective, this is the same principle that powers nuclear reactors on Earth, where atoms are split or fused to release energy. The energy created in the sun's core takes a long journey outward. It starts as high-energy gamma rays, but as it moves through the sun's layers, from the radiative zone to the convective zone, it bounces around, sometimes for thousands or even millions of years, slowly losing energy. By the time this energy reaches the sun's surface, known as the photosphere, it escapes as visible light, heat, and other forms of radiation. This is the sunlight that warms our planet, powers photosynthesis in plants, and fuels all life on Earth. The sun produces an astonishing amount of energy. Every second it releases about 384.6 yottawatts. That's a 384 followed by 24 zeros. To put this into perspective, the energy the sun emits in 1 second is more than what humans have used in all of history combined. Yet, despite burning through 600 million tons of hydrogen every second, the sun is so massive that it has enough fuel to keep shining for about another 5 billion years. Eventually, when most of the hydrogen in the core has been fused into helium, the sun will undergo dramatic changes, swelling into a red giant before shedding its outer layers and leaving behind a dense core called a white dwarf. So the next time you feel the sun's warmth on your skin or see a golden sunrise and marvel at its brilliance, ask yourself, what will happen to life on Earth when the sun's light finally begins to dim? Remember, you're experiencing the result of countless hydrogen atoms smashing together deep inside the sun, creating energy that has traveled millions of miles to reach you. The sun isn't just a fiery ball in the sky. It's a colossal nuclear reactor, tirelessly converting mass into energy, giving life to our planet, and lighting up the universe. And as you stand there, think about this. One day, billions of years from now, the sun's light will fade. But for now, it burns on, fueling the very essence of life on Earth.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.